Alright, so in this lab here, we're going to be measuring a few masses and volumes to determine the density of 3 solutions. Right now I have tap water in the burette here. I'm going to be switching it out for a saltwater solution and a methanol solution later on. Technically, to find density, all you need is sort of one mass and one volume reading, but just to hopefully minimize some random errors here, we're going to take down many different masses at incremental volumes. We're going to be plotting it graphically with mass on the vertical, volume on the horizontal, and through calculating the slope, hopefully that'll give us some nice average of the density for these solutions. So to start off here, I have an electronic balance. It's already been zeroed. I'm going to be using a beaker to be holding the liquid, so I'm just going to put that on the side here. You could record the mass of the beaker first, so that's 49.28. If you're doing an error, you can do a plus or minus, say, 0.01. What you could do is you can just totally start adding solution right away. If you like, you can actually even zero the scale here. That way we're just measuring the mass of the liquid instead of including the mass of the empty beaker. So I'm just going to try to tear the scale here. Right now here I have my burette at the 0 milliliter marking. So obviously 0 milliliters, I would expect that the mass to be 0 as well. I'm going to go up in increments of 3 milliliters at a time. I'm going to read for you what the burette is saying here, and what I want you to do here is you're going to copy down what the mass says at each increment. So let's just have a quick look here. So I'm going to open up the burette here. So right now my volume here is 3.00 plus minus 0.01. You can record that mass down. Go down another 3 here. Okay, so now I'm at 6.10. So sure, I was a little bit over, but graphically here you can just find that point there. So 6.10 on the burette, and then record that mass there. Let's go down to 9 milliliters. Okay, this one here I'm getting 9.05, also a plus or minus 0.01. The mass there is 8.97. Going down to 12. That one, I'd say 12.04. Again, you can just record down that mass there. Go down to the 15 mark. A little bit more. Okay, so that would be 15.10. You can record down that mass there. I'm just doing increments of 3 just for simplicity. Okay, it doesn't need to be exactly, so I did a little bit too much here, so that's going to be 18.20. So that has that mass there. So we're gonna keep going here, down to the 21 mark here, 21.04. We have that mass. We're gonna go down to about 24. So yeah, that's almost spot on, 24.00. Mass is 23.92. We're going to go down to the 27 mark here, so 27.10. We have the mass 27.07. Keep going here down to the 30. So the volume reading is 30.10. Record down that mass. Go down to 33. Okay. This one here is 33.09. You can record down that mass there. Keep going here down to the 36. So here I have 36.11. We have that mass there. Going down to 39. A little more here. 39.04. We have that mass there. Going down to 42. So this volume reading is 42.00, almost spot on. So we have that mass. We're going to go down to 45. So my volume reading here is 45.02. Remember, burettes can be read to 2 decimal places. You can record down that as a mass here. And one mass reading for volume here. Down to 48.12, and we have the mass of 48.03. So what I'm going to do is I'm just going to swap out the solution. We're going to do exactly the same strategy, but just using a salt solution and then a methanol solution, and we'll go from there. Thanks, guys. Okay, so I've swapped out the solution here. I put the empty beaker back on the balance here. I've zeroed the scale. Now we're ready to measure the same mass volume readings here for salt solution. So again, 0 salt solution, we have 0 mass. Again, I'm going to go up in increments of 3 here. This one here is saturated salt solution. So the volume is reading 3.01. You can record down that as a mass here. Going down to the 6, went a little bit too far there, so this is 6.30. We have mass 6.78. Going down to the 9 here. I'm getting 9.20, so the mass is 9.97. Going down to the 12, we're there, okay. So 12.04, a mass of 13. Going down to 15, remember this is saltwater solution here, that's 15.20. You can record down that as a mass here. Going down to 18, so it's 18.10. You can record down that as a mass. Switching it up for volume of 21, so this is 21.03. You can record down that as a mass. I'm going to aim for the 24 here, so almost spot on 24.02. You can record that down as a mass. Aim for the 27 mark here, so 27.10. You have that as a mass there. Going down to the 30 mark. So this one here, move the Brett a little bit so I can see it. So 30.10, we have that mass. Heading down for the 33, so 33.00, almost spot on. You're recording down that as a mass there. Moving down to 36, right? So 39.49, so 36.00 is the volume there. Let's go down to 39.06. We'll record that down as a mass. Going down to 42. Okay, so 42.00 is the volume. You record this down as our mass. Go down to the 45. So 45.02 is the volume reading. Record that down for the mass. And one last reading here, heading down to the 48. We have 48.00 as your volume, and the mass is 52.56. So we're going to do one last calculation. I'm going to swap out the salt solution for methanol solution, and then we're going to be able to graph this. Thanks, guys. All right, so this is our third solution. I've replaced the solution in the Brett with methanol here. Again, I've dried out my beaker here. I've zeroed the scale. We're going to record down 0 methanol. We have 0 mass there. And again, we're going to aim for roughly about 3 milliliter increments here, and that way we can plot this on the graph. So let's have it go. So methanol went a little too far here, so that's 3.30. There's a mass of 2.66. We're going to go down to the 6. More there. So 6.10 has that mass there. Going down to the 9, so 9.02 has that mass. Going down to the 12, so 12.21. Where's the mass? 15, I'd say 15.12. There's that mass there. Slightly under 18, but that's okay, we'll record it. So 17.95. There's that mass. Aim for 21. So almost spot on 21.00 has this mass here. Down to the 24 here, went a little too far, 24.10 has that mass. Down to the 27, so 27.03 has that mass there. A little shy of 30, so 31.10 has that mass there. Down to the 33. So 33.00 has that mass. Going down to the 36, so 35.95 has that mass. 39.20 has that mass. 42.08 has that mass there. 45.00 has that mass. And one last reading, 48.00 has that mass there. Okay. So what you're going to do is you're going to take down this data here. You're going to be putting mass on the vertical axis, volume on the horizontal. Plot all three data sets, the water, the salt solution, the methanol solution, on the same graph. You can use different markings. You can use different colors. Try to draw a best fit line, and by calculating the slope, you should be able to find the densities of these solutions. Thanks, guys.